One of the easier topics we use is arc length. Now, arc length is a really easy one to pass off as long as you do the equation correctly, so be careful. So here's the problem we have. I want to find the length of the curve of the function f of x 1/3 x squared plus 2 raised to 3/2 on the interval from 0 to 3. The formula we use is the integral going from a to b of 1 plus the derivative squared. Make sure that that is a plus. The most common error is students make that a minus. And every now and then students want to throw a pi in there too. There's no pi. So be careful. So now I'm going to take my derivative, and you got to be careful. I mean, maybe the hardest part of this is just doing the derivative. So when you do the derivative, watch out for chain rule. So I got 3/2 times 1/3. That gives me 1/2 x squared plus 2 raised to the 1/2 times derivative of the inside, which was 2x. So don't forget your chain rule. The 2 and the half will cancel. So I get x times the square root of x squared plus 2. Now what I would do is I'd store that into y1. That makes it easier. Then you basically using this equation. The integral going from 0 to 3 of 1 plus x times the square root of x squared plus 2 squared. Now you might see this answer where they simplify this out. When they simplify it out, they're going to square the x. That's going to be x squared. And I square the square root, it's going to be just x squared plus 2. So you might see an answer written this way. But you're going to use kind of the answer you saw in that first part. You're going to use this idea by storing this guy into y1. Now if I use my function integral, it's the square root, and just kind of cut that part out a little bit, 1 plus y1 squared, because that's what I put into y1, comma x, comma 0, comma 3, and it ends up equaling 12, which may surprise you because they say, oh man, how did we get such a nice answer? Well, I'm going to show you a few more extra steps here, just in case for some reason you're not going to have to do it on a Sig test, just in case they do something bizarre on a non-calculator multiple choice question. So I multiply that out, and I get x to the 4th plus 2x squared plus 1. If you realize, that's actually x squared plus 1 times x squared plus 1. So it's a perfect square. Well, if I take the square root of that, I just get x squared plus 1. Do the antiderivative, I get x cubed over 3 plus x, evaluated from 0 to 3. You plug in 3, I get 27 over 3, that's 9, plus 3 is 12 minus 0. So I just got 12, and that's where it came from. So kind of a creative little problem. But personally, the easiest way to do it is just what you see right here. Plug it into y1, and then use this idea that we just saw.